In the vastness of space, where orbits appear stable and planets seem locked into eternal paths, subtle forces are always at work. Planets do not exist in isolation. They feel each other's pull, tugging and shifting ever so slightly over millions of years. These gravitational dances sometimes lead to dramatic outcomes. And now, thanks to the James Webb Space Telescope, astronomers have recorded one of the most astonishing planetary events ever witnessed, an enormous collision involving Neptune, the farthest known planet of our solar system. Neptune has long fascinated scientists. It sits on the outer edge of the planetary family, shrouded in methane-tinted skies and whipped by storms that roar with winds faster than the speed of sound. Its dim rings, pale compared to Saturn's grandeur, and its strange climate patterns have puzzled observers for decades. But until now, no one had seen evidence of such violent upheaval on this icy giant. Webb's instruments have revealed unmistakable signs of a catastrophic impact, one that ripped through Neptune's atmosphere and left chemical and thermal disturbances that still echo across the planet. This detection is not just another curiosity in planetary science. Neptune's position makes it a frontier world, standing as a guardian at the doorway to the Kuiper Belt, a region filled with frozen bodies, asteroids, and comets that often stray into planetary paths. The timing of Webb's observations was extraordinary. Instead of the usual dark storms or drifting clouds, the telescope recorded colossal waves of heat and chemical disruption spreading across Neptune. These signatures were not of natural weather but of an external intruder, a body crashing into Neptune with unimaginable force. The identity of the object remains uncertain. It might have been a Kuiper Belt fragment, perhaps only a few dozen kilometers across. Yet even something that small, when traveling at incredible speeds, carries enough energy to alter an entire planet's atmosphere. Webb detected temperature anomalies spreading downward through Neptune's layered clouds, disrupting methane concentrations and reorganizing storm patterns. At the equator, sudden surges of infrared light betrayed the shock of the collision. What makes this remarkable is that Neptune is so massive, over 17 times the mass of Earth, yet even it cannot shrug off such blows. For scientists, this event is a treasure trove. Unlike Jupiter or Saturn, whose thick magnetic shields and massive size deflect many intruders, Neptune's protective layers are thinner. The aftermath of the impact was visible in the turbulence of its skies. This gives researchers a rare chance to study a live experiment in planetary chemistry. How does an atmosphere recover from trauma? How do storm systems evolve after such a sudden injection of energy? These questions can now be answered by watching Neptune heal in real time. Webb's keen sensitivity also revealed something unusual about Neptune's rings. Normally faint and easy to overlook, the rings showed disruptions during the same period as the collision. Shock waves may have traveled outward from Neptune, disturbing the delicate dust and ice in orbit, creating temporary clusters that betrayed the force of the strike. For the first time, astronomers can see how a planetary impact ripples not only through an atmosphere but also across rings and space nearby. The implications extend further still, to Neptune's moons. Triton, Neptune's largest and strangest moon, already stands apart with geysers of nitrogen gas and an unusual backward orbit. Webb detected changes in how Triton reflected light during the collision, suggesting its frozen crust may have been stirred, either by falling debris or by gravitational tremors that passed through the Neptune system. If true, then one impact altered not just a planet but its moon as well, reshaping one of the most mysterious worlds in the solar system. This discovery forces scientists to rethink how safe the outer planets really are. For years, impacts of this magnitude were believed to belong mostly to the solar system's violent youth, billions of years ago. Neptune's collision proves otherwise. Even now, in the supposed calm of the modern solar system, chaos still lurks. If Neptune can be struck so dramatically, then Uranus, Saturn, and even Jupiter may also experience such events. The solar system is not a finished creation. It is alive, restless, and unpredictable. Webb's unique capabilities are what made this breakthrough possible. Hubble and ground-based telescopes could never penetrate Neptune's thick methane haze to capture such fine details. Webb's infrared eyes, however, peeled back the layers, recording signatures across the full spectrum. That data is now being used to model impact dynamics, how shockwaves ripple through a planet's gases, how chemistry redistributes itself, and how long weather systems take to stabilize. And this is not just about Neptune. By studying this collision, scientists gain insight into exoplanets, giant worlds orbiting other stars. Many of those planets are even larger than Neptune, some much closer to their stars, and subject to frequent bombardment. What Webb saw here can help astronomers interpret the violent histories of distant alien worlds. There is also the broader cosmic perspective. The Kuiper Belt is no quiet graveyard of frozen rocks, it is a restless population of wanderers. Neptune, by its sheer gravity, shapes their paths, pulling some inward, flinging others out to deep space. But that role comes at a cost. By protecting the inner planets, Neptune exposes itself. It is both guardian and victim, absorbing the blows of the solar system's debris. This collision is a stark reminder of that dual role. The event also sheds light on Neptune's strange interior. Unlike rocky planets that record impacts as craters, Neptune swallows them into its thick gaseous layers. Shockwaves move downward, heating gases and disturbing winds. For decades, scientists could only guess at Neptune's internal structure, since no spacecraft has orbited it. Now, with this impact, they finally have clues. The way energy rippled through Neptune reveals how dense its layers are, how heat moves within, and how its deep atmosphere is organized. Even Neptune's famous supersonic winds might be linked to such collisions. They are the fastest in the solar system, reaching over 1,200 miles per hour. After the impact, Webb recorded changes in wind speeds at certain latitudes, suggesting that outside forces may feed or disrupt these extreme currents. Perhaps Neptune's violent winds are not just internal quirks but the legacy of repeated cosmic bombardments across its history. Its magnetosphere, too, showed signs of disturbance. Neptune's magnetic field is tilted and offset, unlike Earth's neat alignment. For decades, that oddity baffled scientists. Webb detected shifts in charged particles after the collision, hinting that impacts may temporarily alter Neptune's magnetic behavior. If true, then collisions might even help explain why Neptune's magnetism is so irregular. The heat signature of Neptune is another puzzle. Despite being farther from the Sun than Uranus, it emits more internal heat. For years, scientists wondered why. Webb's detection of a post-impact infrared surge may provide the answer. Perhaps Neptune's warmth comes not only from internal sources but also from periodic bombardments, injecting energy over time. This discovery changes how we think about planetary protection and cosmic history. Earth, shielded by Jupiter and Saturn, may owe part of its survival to the outer giants absorbing or deflecting intruders. Neptune, sitting on the edge of chaos, takes the brunt of that role. This collision is both a scientific revelation and a cosmic reminder that even worlds far larger than Earth remain fragile under the endless bombardment of space. The James Webb Space Telescope has turned Neptune from a distant mystery into a stage for planetary drama. Each ripple in its clouds, each disturbance in its rings, tells us the solar system is not static but alive with motion and risk. For humanity, this is more than a scientific event. It is a story about endurance in a violent cosmos. Neptune may be far, but in its turmoil, it reflects the same cosmic forces that shape every planet, including our own. And thanks to Webb, we are now witnesses to one of the most powerful planetary impacts ever observed in real time. The outer solar system, it turns out, is not quiet. It is roaring with events still waiting to be discovered.